This is Chapter 1, Section 1 of Statistics, Statistics 1. So the statistics is the science of conducting studies to collect, organize, summarize, analyze, interpret, and then draw conclusions from data, right? Because statistics is essentially a data science, right? It's not really a math class, and it's not an exact science either. So you want to collect data, and then you want to organize and summarize it, which is what we're going to do in chapters 1 and 2. We're going to, have data sets and make graphs and tables and all that stuff. Then the analyzing and interpreting of the data will come later, once we do all the calculations in the later chapters. And then finally, we want to draw conclusions, right? Conclusions, which is the last step. And we do our best to come up with the best conclusions, but it's not an exact science, right? So basically, you have descriptive and you have inferential statistics, which has to do with those conclusions, basically. So descriptive is you just take the data, you don't do anything with it, really, you just summarize what you found, okay? That's drawing a conclusion, but typically what we want to do and later in the course is inferential, which is when you infer as to an outcome, basically. So what you're essentially doing is you cannot get all of the data from the population, right? Essentially in statistics. Very rarely can you. So you actually want to do a sample which is smaller than that, right? And you'll do your calculations, you'll analyze it, and then you'll infer back to the population as to what you think. Is it a perfect? No, because it could be wrong, but you're doing the best you can by getting the best samples you can, the largest samples you can, such that when you do the calculations and analysis, when you infer back, it actually gives you a good picture of what the population actually is. Okay. So look at two situations here about statistics. We have a situation about credit cards and a situation about football. So in the first one, I took all the credit card purchases for 6 months and put them in a chart, basically. And I'm just saying this is what they are. I didn't do anything with them. I'm just saying, hey, this is what they are. That's descriptive statistics, right? However, if I look at 3,000 football game scores and I analyze those, compare the point spreads, and then I look back at the point spreads the odds makers say, and I say, oh, those are pretty good based on my findings, I'm inferring as to what I believe, basically. So I'm inferring back, because this is not all the football games, obviously. There's been way more than that over time. I'm just taking a sample of those and inferring as to what I believe the population is. And I'm saying that the odds makers are generally good at their job, basically, is what I'm saying. Maybe I'm wrong, maybe I'm right, but based on the data that I found, I'm saying that they're correct. Okay. Variable. A characteristic or measurement that can assume different values for each member of the set. Okay. A variable can be either numeric or categorical, which we'll go over the different data types. That's very important. It's a different type of data. We're going to go over that in upcoming here, because that also tells you what kind of test you need to do. So a data set is the collection of the elements, basically. So the individual little guys are called elements, basically. So a sample has elements. They might not be people. They could be stars or widgets or cars, whatever the thing is you're actually studying. So datum is the single data value, right? That's often misunderstood because they kind of go back and forth between these, but datum is the appropriate word. Okay, so if you have all of the elements being studied, okay, that's the population. Okay, so when you go to collect this, it's either going to be a census or a sample. Okay, so you're collecting from the populations a census or a sample. If you get them all, which is basically impossible in most cases, or pretty close to it, you've got all the members, right? But typically you're going to be doing a sample, which means you only got a sub-collection of the data, okay? Which means we need to do some calculations and inference back to the overall population, right? So the key is you want to get the samples from the overall target population. So one thing you'll see in books they don't always do well is they talk about population, but they don't necessarily reference the target population. Okay, so the target population is probably smaller than the regular population. It might not be, but it traditionally is, basically. So let's say you want to do cancer rates for people in the world, right? The population is just people. Okay. So the target population is just people. However, let's say you want specifically cancer rates in New Hampshire. Then this changes. Now the population's people, but the target population is New Hampshire residents or New Hampshire people, correct? And the sample is even smaller than that because I'm not going to be able to get every single person in New Hampshire to figure out cancer rates, right? That's too difficult. So sometimes these are the same, sometimes these are not, but in most cases they're not. So target population is a more precise way of going about it, though. Okay. So in this case over here, the population and the target population are the same essentially, right? So that would be the cancer rate one, right? Whereas this would be the New Hampshire one, right? Okay, and each individual one is an element. So if I'm doing like cars, right? Let's talk about cars. If I want to figure out the average repair cost on cars, right? That'd be this one, all cars. And I take a sample of some cars, so it's not people, right? Over here, let's say I was going to do Toyota, right? Well, the population would be cars. My target population is Toyota cars, and I'm going to sample some Toyota cars. So in this example, that would be specifically that. So, you know, population could be cars, people, who knows. Okay, so is the following a sample or a census? What's the population and the target population? So the price of high school senior trips is outrageously expensive. You suspect some members of the senior class have not paid their dues. You ask every member of the senior class if their dues are up to date and conclude 72% have paid in full. Well, here's the key. You asked every member, correct? So the target population is different than the overall population because the target population here is the high school seniors at your school, whereas the population is high school seniors, which may not be in your school. And the key is it's a census because we get everybody of the target population. That's the key, not the population. Versus a U.S. census, right? They collect citizens and non-citizens in every town every year. You've probably seen this if you're old enough. You should be when you're in college. If the census collects at least half the people in the town, it's considered successful. That's not actually true. It's far less than that. But when I say it, the actual number, people don't believe me. The census used by Congress to appropriate funds for the next 10 years and congressional seats, but we won't worry about that. It's not really the point of the problem. So the key here is, right, you have people, but the target population is U.S. residents, right? So if you don't live in the U.S., we don't really count you here. And the question is, did we get everybody? Well, yeah, it's called a census because that's what we want, but we never actually get it. We actually get samples because we only get part of the U.S. residents, basically. Okay? All right, so when you get actual data, the actual data is a parameter or a statistic. They used to call these the full words, which are population parameter and sample statistic back in the day, right? So if the data thing that you have involves everything, right, that's a population parameter, basically. If it doesn't involve every single element, then what you have is a statistic, okay? Which means you have to do a statistical analysis at that point. So let's say we are down here, and we look at the fact that Lincoln got this many votes, right? Out of that many. Yeah, okay, right? Well, is that a population parameter or sample statistic? Well, the population is all the U.S. residents, but not everybody voted. So the target population is the voters. We have all of the voters, right? So since we have all of the data for all of the voters, that is a population parameter. We know for sure. We don't need to infer anything. We know the answer. Whereas 877 executives said they would not hire somebody with a typographical error in their resume. Hopefully there's none in my notes. There might be. Who knows? Well, 877 is not every single executive in the whole world. So therefore, whoops, that's not typo there. I'm sorry. I'm going to infer back that's actually reality, because I don't know for sure, because this is not the entire population, basically. Okay, the last thing is probability, which we'll be doing in Chapter 3, so we'll come around to this, basically. So probability is a chance that an event occurs. As to what that event is, it could be anything: flipping a coin, picking a card, rolling picking a ball out of a hat, who knows, right? And you have to conduct probability experiments, which we'll do in Chapter 3. Which is looking at the outcomes, and we'll define outcomes more precisely in Chapter 3 and what those particularly look like. So what we care about at that for here is if things are fair. So fair is a is if they're equal, basically, equal chance of happening. That's what that essentially means. This is a standardized probability term across all, probability books and courses. Basically, it's an accepted term that it means this basically. So let's look down here to give you an idea. So if you roll a 20-sided die in a role-playing game. Let's see. You'd roll a 20-sided die in role-playing card games. Yeah, that's right. The die used has a probability of 0.05 for any given side. Well, that sounds fair. So if the die actually comes out 1 out of 20, that's fair, because that means every side of the die will actually be 5%. That would be fair. Chances are, though, if you buy a die in the store from those gaming stores or gaming shops, the actual probability that you're going to have a fair die is slim to none. The actual fair die, which means every side has equal chance of being rolled on, are extremely expensive. We're talking hundreds of thousands of dollars, because actually making a fair die is quite difficult. It's actually easier to make one that's loaded, which means one side is going to happen more than others. So if I roll a standard 6-sided die at the casino, right, and the 6 keeps showing up 25% of the time, even if I roll it 200 times, okay, well, here's the thing. 1/6 is 0.16 repeating, which is not 25%. So that means this is a loaded die. That's not fair, right? Because they're all equal chance, which means the 6 happening more than 1 through 5 essentially on this die. All right, well, what if we flip a coin 2,000 times, we get 995 heads? Well, you're like, well, that's supposed to be 1,000. But honestly, if you flipped a coin 2,000 times, is it going to equal 1,000 every single time? No, it's not. Okay, chances are you're going to be plus or minus within a margin of error, basically, of the 1,000 heads, which is what you should get. You know what I'm saying? And that within that margin of error, which is called a confidence interval, is close enough. So that's close enough to consider it fair, essentially. Okay, that is the end of section 1.